Welcome back friends in new series of artificial intelligence for all by Explore It. So friends, what is AI? Artificial intelligence is an area of computer science that emphasizes the creation of intelligent machines that work and react like humans. So basically what is AI? It is basically area of a computer science in that we are working on a machine, on a device which works and behaves like a human. It can be that's not necessary. Definitely it perform all the actions that human performs, but we can develop any machine or any small device that works like a human. It's clear written that reacts like a human. So the core problems of artificial intelligence include programming computers for certain traits such as. So basically AI has certain problems on which it is working to make it a solution. Basically that is knowledge. If we have a knowledge, so we can interpret in any machine or any device, and it is making a reasoning. Reasoning is a main reason behind the AI, that how devices are working, which technology I need to use, which label I need to assign, which type of data is needed, and all these things which we will study in further. Problem solving, definitely there are if I talk about the puzzle game, the small puzzle game, so definitely in that there is a lot of logic. And if we talk about the biggest scenario, so in that problem solving is one of the problem which AI is facing, because it's a deep concern that how to solve a problem. And perception learning, how can we learn the perception of someone? Suppose if we are talking about self-driving cars, so if the signals are not clear and the weather is gloomy, sometimes we are not having a proper traffic, so how the self-driving car will work. And planning ability to manipulate and move objects, in which situation the objects will move. If you are talking about the vacuum cleaner, small vacuum cleaner, that is smart and it's taking decisions, so how we can train that our system, how can we make reason, and how we develop the ability to vacuum to take a decision. After that there are, what are the type of AI? ANI, AGI and ASI. ANI, artificial neural network, artificial general intelligence, and artificial super intelligence. So if we talk about the broader aspect in which we have worked a lot, that is artificial neural network. And what is AGI future? That is artificial general intelligence. And if we talk about artificial super intelligence, that is possible. They are asking, is that possible? Because it's something very new that is not till developed. But AGI, we can say that we are having certain robots, that was Sophia, that behaves like a human or more smarter than human. That is artificial general intelligence. In that work is very little done, but artificial neural network, much work is done in that. So much detail about artificial neural intelligence. If we talk about object detection, tracking, text classification, machine translation, speech recognition. Speech recognition is that if you are speaking in someone else's laptop or in someone else's PC or in smartphone, that's Chinese is there, so how can that system interpret the meaning? Object detection, definitely in we can see that Google Lens is one of the best example for that. Just we show the picture and it detect that what is talking about. And if we talk about tracking, text classification and all that are not new. And artificial general intelligence, what actually do humans do? In that the system exactly does what the human does, or it can be more smarter than that. That we develop a system that is more smarter than human. There are so many movies we have, but that's not actual implementation till now. Sophia robot is there. So further, machine learning. What is machine learning? Machine learning is basically the branch of artificial intelligence that concerns the construction and study of system that can learn from data. Definitely, if we talk about machine learning and if we don't about data, that is impossible, because machine learning is totally depend on data. The larger the data we have, the more stronger and possible result we can achieve. So the goal of machine learning is to build computer systems that can adapt and learn from their experiences. So that was said by Tom Dieterich, that what is the goal of machine learning is that computer system can adapt and learn from their experience, and from where that experience comes from data. The more or the stronger data we provide to our system, that the more it learns. Like suppose if we are using Facebook and whatever we are searching, if suppose I am searching about artificial intelligence, so in my FB all the ads will be of artificial intelligence. In my YouTube wall all the ads or all the links will be of artificial intelligence, and whatever we are searching it shows the data similar. So our machine learning is using the algorithm. On that basis it takes decision. Algorithm type machine learning algorithm can organize based on desired outcome. Definitely each algorithm is designed for the desired outcome. We give or we type of input available during the training machine. So basically the two type of algorithms we use. One is supervised learning. So what is supervised learning? In that supervised learning we provide input and we provide label. On that basis of input and label the decision is taken, and that's most widely used learning technique. It's an example. We can see that here we have a data set, and here we have data set, and that is splitted. Let me show you again. That is splitted and training data, and that is test data. Okay, after that we have train model and score model. So what we have done, we have a data, and after that we have assigned label to that. We can take example from another perspective, that how supervised machine learning works. We are having Google Assistant in all of our mobile phones. So whenever we give or order to that assistant, it takes as an input, and already that system is trained and it takes decision on the basis of that. After that, what is supervised learning algorithm? Definitely are trained or labels. In that we provide training and labels. As I said before, input what the desired output is known. So we give input, and on that basis desired output is known to us. Suppose if I assign the label to cat, so I know that in return it will say yeah it is a cat. If it says it's not a cat, so that means that that's violating the law, and it's the problem which AI face, which we further discussed. So what is unsupervised learning? Unsupervised learning operate on unlabeled example. In that we don't label the example, basically in input where the desired output is unknown. In unsupervised learning we give input, but the output is unknown to us because we are not sure about the output. So that because we didn't train the system, without training the system we are expecting the output, so definitely that is undesired or unknown. Like here we are having a raw data, and on that basis of raw data we have assigned that to algorithm, and it has clustered. What it has done, it has splitted that in different type of red, yellow or blue colors coins. We can say that it has splitted the data by using the algorithm, but we didn't expect the output what could come. There could be combination of output, sometimes red or blue, red or yellow, so the output can be different, and the output that's totally depends on the algorithm which we assigned. So that is the example of supervised learning. Here we have given the input and we assign that these are apples, so definitely the output what will come, it is an apple. But in unsupervised learning, what we have done, we have assigned different fruits, apple, banana and apricot, and we ask the model to learn that, to apply the algorithm, to apply the to apply that equation. So what it has done, it has converted into groups, or we can say that it has converted into a clusters. What are the clusters? It has separated the class of apples, apricots and bananas. So further we will talk about the data, because supervised learning is totally depend on the data. So let's proceed further. Okay friends, but before proceeding to data, I want to share that examples with you, people of artificial narrow intelligence. So what is the artificial narrow intelligence example? Smart speaker. Definitely in that we give A to B mapping, and we'll further study, but here it's be precise that smart speakers, that is definitely it's performing a single task, self-driving car. A AI to do web search. It's performing web searching. Definitely it's also based on narrow intelligence. And after that, AI application in familiar farming or in factory. So there are so many farming factories in UK or in Pakistan, or apart from Pakistan or UK, there are many countries that they are using AI applications in farming or in factories to make their production more better. Further, what is artificial general intelligence? Like I gave you example of Sophia board, and here there is example of kind of super person. So that is performing a task better than human or equivalent to human. So there is progress in AI versus AGI. What they are saying, that definitely there are a lot of work is done in AI, but much work is needed to be done in AGI, which is leading to some irrational fear. Definitely there are fears if we make a system equivalent to humans, so there can be evil clever robot coming over to take over humanity any time now. So definitely there is a fear of creating the robot that works like a human. So after that, what they are saying, that achieving AGI will take time. AGI is an exciting goal of research to do work, but it requires many technological breakthroughs before we get there, and it may decades of hundreds of years or thousands of years. Definitely AGI, artificial general intelligence, is not a work of an hour or years. It is definitely a work of thousands of years, because it's very difficult task to develop a system that is exactly like a human. So these are the example of supervised learning. I have explained you before in detail what is supervised learning. So we can shortly say that to a to B mapping. What is A to B mapping? A is input and B is output. When we map A into output, then we get the application. So input is there, we give audio, and in output we give text. Definitely I am giving the audio and I want that audio to be converted into text. We can talking about the speech recognition. Okay, so as a result, what we are getting, our speech recognition application is ready. After that, what we are talking about, machine translation. It's another interesting feature of supervised learning. We are giving the language of English and we want that English to be converted into Chinese. So what the machine or application is doing, that it translate. After that, what we are having, input, we are having advertisement. Okay, so we want the user to click that ad, to click that bar. So what we are doing, we are showing the thing of their interest. Suppose I want that person is interested in AI stuff, or the person is interested in medical stuff. So what the programmer does or do is that that person make an application like that, or attract the user through the advertisement. What they are showing the advertisement on which we get attracted and click that. After that, what we are having, self-driving car. In self-driving car, we are giving the input in the form of image, in the form of radar. So what it does, it identify the position of other cars. On that basis, it taking decision that where I have to move forward. And further, what we are having, a mobile phone, that is visual inspection, which is helping manufacturer to reduce or prevent defect. That the visual inspection is doing what, it is finding that which mobile phone is scratched one. So output, we want that to detect the correct mobile phone. So it detect the scratched mobile phone and it pick the correct one. So that is all for supervised learning, A to B mapping. So what we are saying, what is now we are having traditional AI, that is the minimum level of performance. And the more we provide data, so the more performance of system will be improved. And the medium data, definitely more performance will improve. And if we larger the data, the larger the performance. So now let's move towards the data. As I said before, so basically data is any raw fact or figure which we studied in our previous classes. So here, what is data? Data is everywhere. If we talk about our cell phone, in our cell phone, data is everywhere in the form of PDF. We are having documents, our books. We are having audio in the form of songs, in the form of our lectures, in the form of recording. We are having a videos. We are having a raw data. We are having a picture and text. So we are having data all around. So in AI or in machine learning, the more the data we have, the more the system performance is improved. and we can provide any kind of data according to our need. So basically in here we will study about tabular data, and in tabular data you know that we are having a rows and column, and rows are called rows and column will be called as features. So here we will implement the data in A to B mapping in supervised learning. So let's have a look at examples. So this is the example of data. In that we are having a size of house and price. So we have given the input and we want, on the basis of that input we predicted the output. Suppose I am saying that the size of house should be 523 feet, and so what would be the price? So we can predict that the price will be of $115. So that is A to B mapping. We are giving the input A and we give the output B. Now we increase the size of data, and what the new things we have added, the bedroom. So here we can give two inputs. On the basis of that input we can predict the output, and that input can be size of house and number of bedrooms. Suppose I am saying that I want the size of house in 645 feet and the number of bedrooms should be 1. So what could be the price? The price could be 150. On the other hand, I am saying that I have a budget of $280 and I want the bedrooms of 3 rooms. So what would be the size of house? So definitely the size of house would be 1034. So on the basis of given data we are doing what we are doing. We are predicting the output and we are planning the system to make a certain decision. So again I am repeating my sentence that the more the data we have, the more our system could be learned. Okay, so data is often unique to your business. Definitely in our business we are also having a data, so there can be a data of different types. It's up to you to decide what is A and what is B. As I said before, you can make a difference in A and B according to your need. So your decision maker or your business analyst or your system analyst will decide that how to make your system more stronger.